Okay, so you don't need to write all this down, but I want to go through it, and I just wrote something basic that I'll kind of do with you in a minute here. So it said when we studied differential calculus, so finding derivatives, we saw how to find the rate of change of a function by differentiation. So what I was taking that when we take the derivative of y, we get dy dx. And what that is saying is we're starting with an amount. When you take the derivative of an amount, you find the rate of change. The derivative tells us the rate of change of a function. Now what we're going to do is do the reverse process. So now, so when we integrate a rate, when we integrate dy dx, we get y. When you integrate a derivative, you get y. So when we integrate the rate, we get the amount or the overall change in quantity. Okay? So it can be used to measure the change in quantity. So we're going to find the amount of something here. So what I just wrote down was kind of the basic stuff I wrote in the notes, just right above the example, however you want to do that. Okay, so when we're talking about real world things, I'm just going to tell you the functions are miserable. The book actually went through and did the antiderivative of all of this and did most of this by hand, but you're going to have to plug it into the calculator anyway once you plug the values in. So to me, I think it just makes sense to use Math 9. I used my GDC and just did Math 9. Now, so be careful, because what happens is you're going to do your Math 9, your integral from 0 to 12, and then when you start plugging this in, we're going to go 0.3. As soon as you type sign in, a parenthesis pops up. I would use the fraction button, the alpha y equals, parenthesis, and I wouldn't use t, just use x because the calculator doesn't know the difference, minus 10, and the parenthesis, over pi, over 12. This is the important part. You must end this parenthesis before you get started on the next part. Plus, and then finish out the rest of this equation. Make sure your calculator, anytime you're using sine and cosine, this is using pi. Check your mode. The mode should be in radians. Anytime you're entering pi in as a value. All right, so when you plug all that in, hopefully you get 7.13. That's gigawatts per hour, gigawatt hours. Okay, if this didn't work, bring your calculator tomorrow and I'll work with you. So it wants to know what they represent. What is this finding? The rate of power consumption. So the rate of the consumption can be modeled by that function. So what do you think 0 to 12 means? Is from midnight to noon. So we're going to say the morning consumption is 7.13 gigawatt hours. Then letter B, here's where it's kind of slick. What you can do, just take your up arrow and grab all this, hit enter, and when you come down, go all the way back through and change your values here from 12 to 24, and you don't need to re-enter everything. So I'm just going to call that EFT DT. Okay, and enter that in, and hopefully this one comes out to 11.285 gigawatt hours. So this is from noon to midnight. So this is the afternoon consumption. Actually, afternoon, evening. And then letter C, from 0 to 24, is your daily consumption, your total consumption for the day. And really, we can just add these two. And 18.6. This was 0.35 gigawatt hours. All right. So you can either do this or you can just add these two together. But either way, that should be it.